2025 A-Level Combined Mathematics Paper 2 Part B, question number 17, Part A. Part B of this same question will be discussed in a future video, link in the top right. Part A of this question has to do with probability. The question says, a box C contains 2 black balls and 2 white balls, and a box D contains 2 black balls and 1 white ball. These balls are identical in all aspects except for their colors. Now the reason they say this is so that when you choose a ball, there is no bias for choosing either black balls or white balls. It then says, first, one ball is transferred at random from box C into box D. So basically we close our eyes, we put our hand into box C, we randomly choose a ball and we transfer it into box D. So after this they say, after that, a ball is transferred at random from box D back into box C. So after transferring the first ball into box D from box C, we close our eyes again, put a hand again into box D this time, we swirl it around, choose a random ball, and then transfer that ball back into box C. After doing this, we say, finally, now a ball is drawn at random from box D. So this is going to be a drawing ball. So after doing these two transfers, we once again close our eyes, randomly choose a ball from box D, take it out, and call that our drawn ball. So when we draw this ball, it says we have to find the probability that, first off, the ball drawn from box D is white. And then we have to find the probability that the ball transferred first from box C into box D is black, given that the ball drawn from box D was white. So basically, we need to consider the transfers here and then first find the probability that when we complete this process and we draw a ball from box D, the ball is white, and then find the probability that the ball transferred initially from box C into box D, which is the first transfer that we did, was black, given that the last ball that we took out was white. Now in this situation we can see a lot of different things can happen and there's a lot of different trees that we could take. So for each of these branches, what we're going to do in order to consider all of the possible situations is to draw a tree diagram. So considering situations that we could have, we initially have two boxes, box C and box D like this, where box C had 2 black balls and 2 white balls, and box D had 2 black balls and 1 white ball. Now from this initial condition, what we're going to do is to draw a tree diagram of all of the possible different things that could happen. Now considering this, the first thing that we do is to take a random ball from box C and take it into box D. And then we take a random ball from box D and take it in box C, and finally we take another random ball from box D. So considering the first thing, for the first thing we're going to draw a little node, let's say over here, and then we're going to consider the different possibilities that could happen. So here, when we're choosing a ball randomly from box C, we could either choose a white ball or a black ball. Those are the two possibilities. So there, we could either choose a white ball or a black ball. So in our tree diagram, I'm going to draw a branch upward like this, and that branch is going to represent choosing a white ball for the first box, and I'm going to draw another branch down like this, and that branch is going to represent choosing a black ball from the first box. So we're going to call this first branch here the first transfer branch. So I'm going to label it up here, first transfer. So in the first transfer, we have a total of 4 balls inside of the box, where 2 of them are white and 2 of them are black, and if we choose at random, then the probability that we choose a white ball is going to be equal to 2 over 4. And similarly, if we choose a black ball at random, since we have 2 black balls and 4 total balls, the probability of choosing a black ball is also equal to 2 over 4. Now after that, when we choose that ball and put it into box D, we then need to take a ball randomly from box D and transfer it back into box C. Now when we do this, this event is actually dependent on the previous thing that we did, because when we take the ball first from box C and transfer it to box D, we are altering the contents of box D, and therefore we are changing the probabilities of the things that could happen when we take a ball from box D. So therefore we need to go along this branch, and from this node here on the branch, we do again to a split when we choose either a white ball or a black ball. Now considering first the top branch, in the top branch we are saying we choose a white ball from box C and transfer it to box D. So if we do that, the contents of box D are going to become 2 black balls plus the original white ball plus the new white ball, which is going to be 2 white balls. So therefore box D is now going to have 2 black balls and 2 white balls. So if box D has 2 black balls and 2 white balls, now considering the probability of either getting white or black, for, let's say, the second transfer here. You can say second transfer. When we take white from the first box to the second box, the probability of getting white again from the second box to the first box is going to be equal to again 2 over 4. Since the second box here, D, is going to now have 2B and 2W, meaning if you take randomly a W, we're going to have a 2 out of 4 chance of taking it. And therefore, the probability of getting a second W from D back into C is 2 over 4. Now, similarly, taking a black ball from box D into box C after taking a white ball from box C into box D is also going to be equal to 2 over 4. Now that's that for that branch. Let's now go to the second transfer for the second branch here, where we chose a black ball from box C and transferred it to box D. So if we choose a black ball from C and transfer it to D, then we can see we're going to have 2 black balls plus the third black ball that we get from C plus a white ball in box D, and therefore box D is going to have 3 black balls and 1 white ball. Now considering that, if we now choose a random ball from this thing, we could either choose a black ball or a white ball, and we can see drawing the branches like this for white ball here and black ball for here for the second transfer, we can see if there's only 1 white ball out of 4 and 3 black balls out of 4, then the probability that we choose a random white ball out of box D is going to be 1 divided by 4, and the probability that we choose a black ball from box D after moving a black ball into box D is going to be equal to 3 over 4. So now we have this. Now finally, after this, there's one more thing we need to consider, which is the final draw that we make, which is going to be a draw of a ball from box D outward. Now considering that, if we choose a white ball from box D to transfer back into box C, then we can see we initially had 2 black and 1 white. We chose a white ball and then we chose a white ball again, which means we gained a white ball in box D, but then we again lost a white ball in D, and therefore we finally have 2 black balls and 1 white ball in D at this particular point. And therefore we consider the probability of getting a white and the probability of getting a black. The probability of getting white here is going to be 1 over 3, and the probability of getting a black here is going to be equal to 2 over 3. Since in total, at the very end here, we're going to have 2 black balls and 1 white ball left in D, and when you choose, we can either choose the white ball, which is going to be 1/3 chance, or the black ball, which is going to be 2/3 chance. Now for the next one, if we consider what's going to happen for a white ball or a black ball, we initially transfer white ball from C to D, which means we have 2 white balls and 2 black balls in D, but then we transfer black ball from D to C, which means we lose a black ball from D, leaving us with 1 black ball and 2 white balls inside of D. So therefore, in that particular case, if we have 2 white balls and 1 black ball, the probability of choosing white finally for the final draw is going to be 2 over 3, and the probability of choosing black for the final draw is going to be 1 over 3. Now then, moving on to the next branch, which is this branch right here. In this branch, if we consider choosing white or choosing black, we can see initially we transfer a black ball from C to D, and then we transfer a white ball from D to C. So considering that initially we had 3 black balls and 1 white ball in D, and then when we transfer white ball out, we're going to have 3 black balls and 0 white balls in D. Therefore, the probability of choosing a white ball from this particular situation is going to be 0 out of 3, and the probability of choosing a black ball is going to be 3 out of 3 or 1. But I'm going to leave it as this: 0 out of 3 and 3 out of 3. Now for the final case, when we have a black ball and a black ball being transferred in both conditions, we have initially a black ball transferred into D, which means we gain a black ball in D, which means we gain a black ball here, so we get 3 black balls and 1 white ball. But then we once again transfer another black ball, this time from D to C, which means we lose a black ball from D, which means we've gone up to 3, but then we lose once we go down back to 2. So we have 2 black balls and 1 white ball in D. So therefore, if we have 2 black balls and 1 white ball, the probability of choosing white there is going to be 1/3, and the probability of choosing black is going to be equal to 2/3. And that is the end of our tree. So we can see the tree here has 3 layers, with the first transfer, the second transfer, and we could call this final thing the draw or something. So we could maybe move this thing a little bit down like that, and we could call this thing that happens right here the draw. So for the draw, we can see, given each of these individual trees, we have particular probabilities of these events happening. So now finally we can figure out the overall probability of getting white, which is going to be the sum of the probability of getting white like this, the sum of the probability of getting white like this, the sum of the probability of getting white like this, and the probability of getting white like this. So I have to add all of those probabilities together, and that's going to be the total probability of getting white in this situation. So we can go down and say something like, let's say, let event X be the event of getting white from the draw. Now given this, what we're interested in is the probability of that happening, which is the probability of event X. Now considering the probability of event X, the probability of event X is the probability sum of all of the individual events that will get us white. So we have this event, this event, this event, and this event. Now considering the first event, for this event to occur, we need this to occur, this to occur, and this to occur at the same time. So for the first one, the probability of this event occurring is 1 over 2, since 2 over 4 is equal to 1 over 2. Probability of this event occurring is again 1 over 2, and the probability of this event occurring is 1 over 3. And therefore the probability of all three of these events occurring in order to get this white here is going to be a half times a half times a third. And to that we need to add the second probability, which if we consider the second white, which is this white, for this white to happen, we need to have this event, and this event. So here we can see for the first event, we have a 2 over 4 or 1 over 2 chance. For this event, we have a 1 over 2 chance. And for the last event, we have a 2 over 3 chance. So therefore, the probability of that happening is going to be 1 over 2 times 1 over 2 times 2 over 3 plus. And then we go to the next one. For the next one, we have this white right here, and we can see immediately 0 over 3 here, meaning that this white will never happen, but we'll still write it out. So for this event, we have a 2 over 4 or a 1 over 2, a 1 over 4, and a 0 over 3. So therefore, if I write that probability, we have a 2 over 4 times a 1 over 4 times a 0 over 3. For the next one, the final one, for this white to occur, we need this event, and this event. So we can see we have a 2 over 4 or a 1 over 2 chance, we have a 3 over 4 chance, and a 1 over 3 chance. So adding that together, we have a 1 over 2 times a 1 over, not 1 over 4, 3 over 4 times a 1 over 3. Now adding them together, we can see the first probabilities give us 1 over 2 times 1 over 2 is going to be 1 over 4 times 1 over 3 is 1 over 12 plus the second thing is going to be 1/4 times this thing, which is going to be, it's going to cancel one of these, leaving us with 1/6, so 1 over 6 plus third event here is going to be 0 since we have a 0 on top here, so plus 0 plus the fourth event is going to be this thing cancelling with this, giving us 1/4 times 1/2, which is going to be 1/8, so we have plus 1/8. Now adding them all together, we can see if we add the first two, we have 1 over 12 plus we can convert this into 2 over 12, which is going to give us 3 over 12, and 3 over 12 is 2 over 8 plus 1 over 8 is going to give us a total of 3 over 8. And therefore, the probability of X occurring, which is the probability of getting white on the draw, is equal to 3 over 8. So we can call this the answer for question number 1. So you can put an I over here to indicate that this is the answer for question number 1. And now we can move on to question number 2. So for the second part of the question, we are asked to find the probability that the ball transferred first from box C into box D is black, given that the ball drawn from box D is white. So we can see we have to find the probability of one event occurring given another event occurring. So this right here is conditional probability, which means we are likely going to have to use the identities of conditional probability to solve this problem. Now considering what we are asked here, we're basically asked, given that we know that the final outcome here is white, meaning it's either this event, this event, this event, or this event, what's the probability that this event right here occurred? So for this, as I define the event of this white occurring as X, I'm going to define the event of this black here occurring as Y. So I'm going to go down and I'm going to say, let Y be the event of black being chosen for the first transfer. Now, given that what we're basically asking here is the probability of that event occurring given that we already have x. So basically what we're looking for is the probability of y given x. So the event that we want is the probability of y given x. Now for this I'm going to use the identity that I know, that if you have some probability of, let's say, a given b, this is going to be equal to the probability of the inverse, which is going to be b given a occurring, times the probability of a occurring divided by the probability of b occurring. So I'm going to be using this identity here in order to turn this thing into some equations of probability that I can easily figure out. So doing that, if I just use this identity here, I can see the probability of y given x is equal to the probability of x given y times the probability of y divided by the probability of x. Now here, if we consider the values that we need the probability of y, we need the probability of x, and we need the probability of x given y. So we can write down each of these: probability of x given y, we can write down the probability of y and the probability of x, and we can find each of these individually and then substitute them into the above formula in order to find the probability of y given x. So for the last one, probability of x, we actually directly know it since we found that in the last question it's 3/8. So therefore probability of x is 3/8. Now, how about the probability of y? Well, for the probability of y is this event occurring, and considering that the probability of that event occurring based on the tree diagram is clearly obvious to be equal to 2/4 or a half. So therefore we can go down here and say the probability of y occurring is 1/2. Now, for the probability of x given y, if we consider what that means, it means we need to have a white occurring given that we got black as the first ball transferred. So given that we went down this branch, we need to find the probability of us getting white, which is going to be this event and this event's probabilities added together. Now this event's probability right here is 0, since the event of this to this being equal to 0/3 indicates that the overall event from here to here and here to here is also going to be equal to 0. So therefore the probability of that half of the event occurring is 0, but for the second half of the event, which is this white right here, we can see we have 3/4 here and 1/3 here. So therefore the probability of this thing occurring is 3/4 times 1/3. So we can go down and say that the probability of the overall event x, which is this thing and this thing occurring, given that the first event y already occurred, is going to be equal to 3/4 times 1/3. So we can go down and write 3/4 times 1/3, which you could simplify to 1/4. So now using this, we can substitute into the above equation and say that therefore probability of y given x, which is what we want, is equal to, and going up we can see substituting into here, we have 1/4 times py, which is 1/2, divided by probability of x, which is 3/8, and we can see this simplifies to 1/8 divided by 3/8, and we can see if we simplify this, we're going to get 1/3, and therefore the probability of y given x occurring is equal to 1/3. So we could say in a sentence, therefore the probability of the first transfer from C to D being black, given that we finally draw a white ball, is equal to 1/3, and hence we have solved this question. So now finally let's discuss the marks award for this question. So in this question you actually don't get any marks for the tree diagram, but drawing a tree diagram will make it much easier to answer this question. So for drawing the tree diagram you don't get any marks, but when you write down this thing and you write down the product of these three probabilities, the product of these three probabilities, the product of these three probabilities, and the product of these three probabilities, for the three products of probabilities that are not equal to 0, which is this one, for this one, and this one, you get 10 marks each. So here, for writing this thing, you get 10 marks, for writing this thing, you get 10 marks, and for writing the final one, you get another 10 marks. You don't get any marks for this thing because probably it's equal to 0, so it doesn't really matter. So you get 10 marks for this one, 10 marks for this one and 10 marks for this one. But that doesn't mean that you shouldn't write this. You should write this for completeness, but just remember, in this particular case, they for some reason did not give you marks for this. In a different paper, they might give you marks for it. And then when you simplify down and get the final answer, you get another 5 marks for the final answer. Now after that, in the second part, when you write down this formula here, when you substitute, for substituting correctly, the numerator of this substitution gets you 10 marks and the denominator gets you 5 marks, and getting the final answer of 1/3 here and writing it out gets you another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.